facility siguro ko mag-review og lens.
So here
Papatanggal
is
siguro ko.
the original problem. The 2,400 Newton force is applied to the pin at E. Determine the magnitude of the force exerted by pin E on member BDE. Neglect the weight of the structure. So here is the original problem. Actually, B is a ruler support. So that's why the equations formulated were complicated. So this time, we can analyze this easily. So let's draw the free body diagram of the entire system. Then let's solve for the reaction at normal reaction at B. Then we draw the free body diagram of the portion BDE. Then from there, we can solve this problem. So take note that we have a two first body member here, which is member CD. Remember the uh, requirement for a body to be considered a two first member. It is bounded by pins at the ends and there's no force in between. So that's why CD is a two first body. So we have the free body diagram of the entire system. So we have AH, AB, R sub B. Let's just uh, assume that all these reaction components are in the positive direction. If we sum up moments about A, then we can solve RB considering counterclockwise positive. So RB times 2.4 minus 2,400 times 4.8 equals 0. So RB times 2.4 minus 2,400 times 4.8 equals 0. Solving for R sub B equals 4,800 newtons. Having found R sub B, we then, uh, if you need to solve for AH and AV, A sub B, we can easily solve that, but not necessary. However, I put the values here so that for those um, viewers and students whose analysis would be different from mine, might uh, use that. They, you may solve AH and AV if you want. Summation forces horizontal equals 0, so AH is negative 2,400 Newton, so it should be leftward supposedly. That's why it's negative. And summation forces Y because RB is 4,800 upward, AV is downward. So it's also negative 4,800 newtons as shown. But as I said, I solved this in the shortest way possible. These reaction components at A are not required. So I draw the free body diagram of BDE and noting that CD is a two force body, we will call the force in CD as FCD as shown in this free body diagram. So we set up two static equation summation moments about C and summation moment about D. There are only two unknowns. Then summation moment about C, for example, we can solve EH because E sub V is will not be involved in that equation. It passes through C. So clockwise positive, EH times 3.6 minus 4,800 times 2.4 equals 0. So E sub H is equal to 3,200 newtons. Likewise, summation of moments about uh, D equals 0, clockwise positive. So we have EH, which is 3,200 EH times 1.2 plus E sub V times 2.4 equals 0. So substituting the value of EH, which is 3,200, we can solve E sub V, which is equal to negative 1,600 newtons. Since we are only required to compute for the magnitude of the force exerted by pin E, it is of course square root of AH square plus E sub V square. Disregarding the sign because it's the magnitude that is required. So the reaction at E, pin reaction at E, or the force exerted by pin A on member BDE is equal to 3,578 newtons. So that's it for this video. I hope that you understood the explanations and the principles involved, calculations. And I hope also that you can solve this problem confidently by your own.